Hello, welcome to STEM by Jim. I'm Jim Matheson. Today's episode, we're going to be digging into the Raspberry Pi a little bit. A brief introduction, show you what it's all about, what all the parts are, how that works, because that plays a lot into our projects around here. Then I'm going to dive into the office here and give you a brief overview from our arcades in the back. Got a lot of woodworking over to the side. Got some more wood projects back here, and this is where all of our Raspberry Pi work is done. I'm going to dig into that too and take you out to the wood shop for a little bit, show you where everything comes together. A lot of my parts and projects come together outside the wood shop, so that's a big part of this too. So, all that, shop, office, pie, and more today on STEM by Jim. All right, let's start digging into the Raspberry Pi. Raspberry Pi is it's a pivotal piece in the makerspace because you could do a lot of projects that are either basic to learn, science, or technology, or engineering, or math. Engineering would be an example of, Robbie here. He's an engineering marvel. No, not really, but he's an object avoidance robot with his two little eyes, so he can detect in stereo, if you will, like we can with two eyes. He's got an Arduino on top of him, though, but he does have the Pi sitting underneath it. So we're going to go into Arduino later in another video, but we're going to touch on the Pi, and building stuff like this starts at the Pi. And you can build a lot of other things we can get into. Streaming devices, media servers. You can do some Bitcoin mining if you want. You can set up some smart devices. You can do whatever you want, really, if you can think it up. Laptops, even small little PCs. Really small, physically, literally. So, where do we begin with this? So, I'm going to use my little pen here and point out some critical parts here. So, critical parts that we need to learn. And I think everybody needs to understand how the Pi, is comprised. Now, notice it's about the size of a credit card, so it's very small, and it's so that you can mount it on the back of something like a monitor, and you can make it like a touchscreen monitor. And we'll probably get into that a little bit later when we try to build a virtual tabletop for D&D, or we'll do some touchscreen fun with it with the Arduino. But the small size of it allows it to kind of get tucked away and just focus all that core functionality in one small space. And we do have cases for it. One of our first projects we're going to do after this is build a custom case for this, and I'll show you that in another video as well. So let's dig in. What do we have? What are our parts? Well, our parts are the CPU. This is a Broadcom CPU. It does have a heat sink on top of it. Heat sink is so that technically the CPU is underneath it. You see that thin layer? You can see that thin layer right there. And then the CPU is underneath that heat sink, which is on top of it. And the same for the RAM chip that's next to it. This has 16 gigs of RAM. So that's the RAM chip, and then it also has a heat sink. So those two elements usually heat up, so we need a heat sink on that to kind of disperse that. And this does come with the kit, so it'll give you adhesive tape, and you'll put it on the bottom. You'll just stick them there, make sure you get them all lined up, because I think mine is just slightly crooked, and it does bug me. But hey, it's all right. Still works the same. So then the next thing is, by the way, this is a Pi 4B, and that's important because it came with a new element called the PoE hat header, which what that does is when you plug it in, you can plug it into a subboard. It creates a flyback transformer and takes the 48 volts that come in from the Ethernet cable. Your standard Ethernet plug, we usually use Bluetooth Wi-Fi, but if you plug it in Ethernet to a router or something like that, it can actually take that 48 volts to the flyback, store it, and drill it back down to 5 volts. And 5 volts is what this runs on. You have your USB-C 5 volt connector right here, but this can actually power it from the Ethernet cable. And how is that good? Well, imagine if you're making a bank of these, just imagine like 10 of these stacked together inside of a router, and you can plug them all into the router just with this cord. So you could actually, you can plug it in here and you can power this with just that cord. So you can get them all into one tight spot, plug them in, and they're all running in parallel or in sequence, over how you want to do it. But they're still powered by this rather than having to run another line for power, you can actually use the line here to power it. So that's new with the Pi B, 4B rather. Things like this one over here running on a smaller Pi. I want to say it's a Pi 3. It's not a powerful one. And they have a Pi 0, which are usually very small for like smart mirrors and stuff like that. They don't really need to do a lot. And I'll get you into another video about how the difference between Pis and when you want to use one. We want to use one like this if we're going to do a lot of processing, like running emulators or trying to run heavy processing on it that may need to, like an operating system or something like that. We want to run our own laptop out of it. That would be the case. So anyway, that covers the Ethernet connection, gigabit Ethernet connection, the PoE hat header. The in this case, it's basic 8 gigs of RAM, but this one has 16 gigs of RAM on board. And then you have your Broadcom CPU. Now you've got the standard, you probably see this in a lot of places, the 40-pin input-output headers. So these are input-output header pins, very similar to what we see on the arcade. In fact, a lot of these, for when you're building Picades, create harnesses that go out to the controllers, and we'll get into that when we start working on the Picade. But you'll have a lot of pin specs and pinouts that'll show you how to hook things up. For example, this case does have a fan, and in this case, the single pin goes to the 4, and the other two go to the 6 and the 8. So, and that will be powered up. If I turn this thing on, the fan will come on, and that's just the pin out for it. But they start counting on the top here. So if you can get a good look at it, you got right 1, like 1, 2, and then 3, 4, wraps all the way down to 40. So like this one here would be so 1, 2, 3, 4, 39, 40, and then any pins in between there counted the same way, just over, wrap down. So that's the 40 pin input output. And then we've got the Bluetooth and Wi-Fi built into here. So those are on board now. Those were not before. It used to have to be a USB plug-in adapter. You had to plug into your USB to get that functionality. But now with the new 4s, it's on board. So you can just take this, fire it up on your machine, go into the config, and we can do that. I'll show you one day on a video how to do that. We go into config, find your Bluetooth or find your Wi-Fi network and just connect to it. Or you want to connect a keyboard or a mouse, just turn it on and you'll go into the config and detect it, so you can do that. I've got a couple of things, like I got a wireless controller for the Picade hooked up right now through it. So that's the Wi-Fi. And then this is the is that the D? Give me a second here. That is, oh, I forgot. Yeah. First of all, before we get to that, this is the big part, is the micro SD slot. So you take a micro SD card, which I actually don't have on me right now. I don't think. Maybe I have one here. I'm not gonna take it out though. Yeah, I do actually. But you'll slot your micro SD card in there, and a lot of times it's either running Emulation Station or RetroPie for the Picades, or it's running Raspbian, or it's running, whatever you want to run. And you can program that and then mount it, put it on here, and let it drive whatever. Or if you hook up to an external device like an audio device or a media server, or you make this a media server and you hook it up to video, then you could just store all your music there, and that could be like 64 gigs of music, which may not be a lot, but maybe make a jukebox out of this, and you've got all that, and you can flash it or add more to it, or you can even FTP it onto the board or through the SD card. So that's the big piece where you add all your new stuff to it, or save to it as well. Anyway, this is the MIDI 2-lane DSi display port. That's for hooking up like a TFT screen that we'll do through the Arduino, or I'll hook a TFT screen into it, and so that'll be a dedicated little screen. We'll do another project on that too. And then over here, correspondingly, this is the camera port, so you plug a camera into it. So if you wanted to do some sort of, I don't know, maybe put this outside and be motion detected, you could do that as well. So what else we got? I showed you the power port. That's the USB-C standard power port, 5 volts in. We got 2 mini HDMIs right here. They just standard HDMI on the other side. You've seen those everywhere, but there's some that have mini HDMIs, and you plug those right in. And as we work on them, you'll see what those are like. Then you've got a standard audio. It's a 2-lane. I'm sorry, it's a 4-pole stereo audio, and just plug that in. Plug it to an amp that'll go out to a speaker. We will wire this up. I'll show you how to do that for one project we're going to do. And then you've got your USB slots. You got USB 2 here, and I'm colorblind, but blue, I believe, is the USB 3. So the middle one is USB 3, the outer one's USB 2. And you can just hook your peripherals to it. You can hook some external storage a device to if you want to. You can even put a flash or a large SD card adapter in there, reader in there, and do it that way as too. Anyway, that's a brief overview of what the Raspberry Pi is like. So next thing we're going to do is, like I said, we're going to take the case. They come with really sturdy cases, and a little shout out to Bill Rose. Bill Rose is really good about their Pis, and I love theirs, especially their cases are really solid. I love everything about them. When you get them in there, they are in there and they are locked and ready to go. So I highly recommend Bill Rose cases. Do I even have it on right? No, I do not. There you go. So, and then when we hooked it up, the fan will be going. But I love this solid, sturdy case. But I'm going to build one a little bit different. I'm going to build a wooden one because I'm going to have to adapt this to a new Pi-Cade I'm working on. And we're going to have some external USB ports coming off that. I'll plug into here. So I'm thinking about building a custom case for this. And we'll get into that in a later video. Anyway, we'll roll over to this one right quick, and I'll show you again how you'll start to recognize some of the things. This is actually a power for charging Robbie up. You can actually charge the batteries on this with the plug. When the batteries are charged up, he fires off and goes. But yeah, we'll get into the Arduino. But it's got a Pi 3 on it. It's got a power button on it too as well. And most of the other stuff is fairly similar on the board itself, but that's one application of it. Anyway, there you are. That's an overview of the Raspberry Pi 4. Well, that's it for today's episode of STEM by Jim. Next episode, we'll probably dig into the Arduino a little bit and show you what the Arduino is made of. So once we have that, you'll understand the two pieces we work with the most, the Pi and the Arduino. After that, I'm going to start a series of builds. We're probably going to start with a fairly simple build. I'll show you how to build a very simple Pi-Cade. It's probably the one I've built the most. And it's almost too simple, but it's a good primer into how a Pi can work and how you can use it, load it up, and get it going. And we'll do some screen sharing on that and walk you through it. Again, if you have any questions, please ask them in the comments. If you want me to see something, hear something, want me to do something, start a project or a walkthrough, let me know. I'll try to set it up. Also, if you could, give me a subscribe and a like, and maybe share this. Try to get this channel to grow a little bit. And it's going to grow in many ways. Right now, it's just organically coming along. So things will change. Setting will probably change. We'll get out to the shop more in the summer. Change it up once we start getting online and doing some programming. Switch over to the cameras, off the cameras to the computers, and do some screen sharing. But yeah, I hope you enjoyed it. And that's the end of this episode. So have a good one. Remember, you've been stimulated. STEM by Jim.